Hello students, this is lesson U7A04. By the end of the lesson you should be able to say I can find surface area and volume of right prisms. Let's take a look. So let's define what a prism is. A prism is a three-dimensional figure where there are two bases that are congruent and its lateral sides are parallel. Well, what does that mean? These are examples of prisms. These are examples of right prisms, because if you look at this, okay, you see these sides, okay, are all parallel to one another, and the top base and the bottom base are congruent. So here, this is a cylinder, this is a square, a rectangular prism, and then this is a triangular prism. In this case, this is what we call an oblique prism, even though they are, even though the prisms, all these sides are indeed parallel, we don't refer to them as right prisms. Can you guess why? Well, that's because the parallel sides there, they do not form right angles with the top and bottom base. So that's why we refer to them as oblique prisms. But all of these are in fact prisms because all the lateral sides and the lateral edges are parallel. What are some day-to-day things that are in fact prisms? Actually, we live inside prisms. We consume things inside of prisms. So this is a classic example of what a prism is, right? These Pringle cans, I suppose that's what you would call them. Okay, they're cylinders. Okay, this D700 Nikon box, okay, is a rectangular prism. Okay, this tent is also a prism. All right, so the cylinder, okay, the radius of a cylinder let me start over. The radius of the cylinder is r, and the length of the lateral edge, aka the height of the cylinder, is h. Write the formula for the volume and surface area. So let's try to figure out what this is, okay? So to find the volume and surface area, first let's try to find out what the surface area is. The surface area, and I'm going to treat the cylinder like a can. And what I'm going to do is I'm going to open up the cylinder like a can, okay? And I'm going to take a scissor and cut right down the side of the cylinder and open it up. And what I'm going to do is I'm going to take an iron it out. Do you see what we have now is a rectangle with circles up top and bottom that are congruent? So in order for us to find the surface area of the cylinder, what we have to do is we gotta, well actually I went a little ahead of myself, my apologies. The volume, let's start with the volume. The volume is the area of the base times the length of the lateral height, right? So it's just base, the area of this, times the height. That's our volume. The surface area is the perimeter of the base, which is what this thing is. That's the perimeter, times the length of the lateral base, okay, or the lateral edge. So that's this guy, plus 2 times the area of the base. So what is that in this case? Well, the bottom here, this is 2 pi r, isn't that right? And then the height is, well, whatever it is, it's the height, okay? That's the height of this guy here. But the radius of the circle is r. So the volume, in other words, okay, is base times height, and the surface area is the perimeter of the bases times the height plus 2 times the area of the base. All right, we're going to try this again. We are going to, again, try to find the area of the triangular prism by using the triangular base as, the area of the triangular base is b, and the length of the lateral edge, aka the height of the right prism, as h. So again, we're calling this h. we're calling the area here capital B. We need to write an expression for the right triangular prism. So again, we're going to approach this the same way. So I'm going to take this, I'm going to open up like I would a box of, I don't know, what are those chocolates called that's in the triangular form? Whatever they're called. I open them up and I iron out the edges, and that's what I get. We call this a net drawing, right? So this net drawing here, I can see that we have two congruent triangles, and then I have three rectangles here. Well, actually, these three rectangles, when joined together, is one giant rectangle. Isn't that right? And isn't this overall length? What is that in relation to the triangle again? Well, yeah, that overall length is in fact the perimeter of the triangle, and the height of this box here, that's still h, right? So actually, the volume of this box and the surface area of the box, okay, is actually in fact very, very similar to the formulas that we developed for the cylinder a moment ago. So the volume is still base times height, right? It's the area of the base times the height. The volume is, again, the perimeter of the base times the length of the lateral base of the lateral edge plus 2 times the area of the bases. Or in other words, the volume is base times height, and the surface area is perimeter times height plus 2 times the base. Let's try this one more time. I take this rectangular prism, and I do the same thing, right? I open up the box, open it, and iron it out. What I have now is, okay, again, I have this net drawing, I have the top and bottom, okay? And again, I'm calling the top here B, right? The area of that green area there, I'm calling that B. The height of this, I'm still calling this H, right? This length of all 4 of those edges added up together, isn't that the perimeter of the base? That is in fact the perimeter of the base. Let's find out what the volume and surface area formula is one more time. The volume, again, one more time, is area of the base times the length of the lateral edge, which is H. Surface area, one more time, it's the perimeter of the base times the length of the lateral edge plus 2 times the area of the base. It's the same formula again. It's the same exact formula. Volume is base times height. It's the area of the base times the height. Surface area is the perimeter times the height plus 2 times the area of the base. So actually, this is the general formula to find the volume and surface area of any prism. All right, now with that said, okay, check out again one more time the differences between the right prism and a oblique prism, right? Check out these differences. So again, we have the vertical, right? The lateral edges there, okay? They are forming right angles with the base, whereas the oblique does not. Same thing goes for a triangular prism. Same thing goes for a cylinder. Same thing goes for any kind of prism, okay, that I throw at you. They're all the same kind of ideas. Now, with that said, okay, suppose all the right and skewed prisms have this, shown below there, all have the same altitude, meaning congruent parallel planes are equally spaced apart between the right and skewed prisms. Which prism will have a greater volume? Will they have the same volume, and why? So what am I saying here? I'm saying that the height here is in fact the same as the height of this guy. Will these two cylinders have the same volume, or will they have different volumes? And if they do have different, which one will be greater and which one will be smaller? Again, one more time, this is H, and the height of this thing is also H. Which one will be, which one will have a larger volume? Which one will have a smaller volume? Well, as it turns out, you thought of this, right? As it turns out, they're going to be the same. Both figures will have the same volume. And we actually call this the Cavallari's principle because, well, let's just read through it. So if in two solids of equal altitude, the sections made by planes parallel to and at the same distance from their respective bases are always equal, then the volumes of the two solids are equal. What does that mean? Well, to put it frankly, and this is the best demonstration I can think of, suppose I have a stack of pennies, right? And I turn the stack of pennies, okay, into an oblique kind of a structure. Can you recognize that both stacks of pennies will be, in fact, the same height, right? Okay, even though one is skewed and the other, one is not vertical and the other is skewed, both of them will have the same exact volume. They're made up of the same quantity of pennies. So it doesn't matter whether it's a right or an oblique. If they have the same height, if they have the same altitude, they will in fact have the same volume. All right, let's try to do some actual practice problem, shall we? A tent is shaped like an equilateral triangle. Write prism where the length of the side of the triangle measures 6 feet and the lateral edge measures 8. Find the volume and surface area of the tent. Round your answers to the nearest integer. So what are we to do? Pause the video to see if you can figure this out. We need to find the volume and surface area. Hopefully you guys had some time to think about this, so let's talk about this. So we're going to call B, again, the area of the equilateral triangle. That's this guy right here. This is the area of the base, okay? Because this equilateral triangle will be the same on the other side, right? We're going to have two equilateral triangles, therefore these are going to be my bases. Okay, so to find the area of the equilateral triangle, what are we going to do? I have a triangle that's 6, 6, 6. I'm going to break this equilateral triangle into half. So therefore, the height of the equilateral triangle, having gone through trigonometry, this is going to be 3 radical 3. Or you can use Pythagorean theorem if you don't remember trigonometry. So the area of the isosceles triangle will be 1/2 6 times 3 radical 3, which is 9 radical 3. So the area of the base is 9 radical 3. The volume will be 9 radical 3 times 8, which is 72 radical 3 feet cubed. Next, I need to find the surface area. So to find the surface area, I'm going to add I need to find the perimeter of the triangle, multiply by the lateral edge, which is 8, and then add the area of the two equilateral triangles. So to do that, I do P times H plus 2B, so the perimeter is 18. The height, or the lateral edge here, is 8, so it's 18 times 8, plus 2 times 9 radical 3. And this all boils down to 144 plus 18 radical 3. Or it's approximately 175 feet squared. A can has a circumference of 10 inches and a height of 4 inches. Find the volume and surface area rounded to the nearest cubic inch. Pause the video to see if you can figure this out. So since the circumference is 10, I immediately know I can then find out what the radius is because I know that 2 pi r is equal to 10. So therefore, r will equal to approximately 1.5915. If I know the radius, I can then find out what the volume is. I can find out what the surface area. I can do anything, okay? It's because the area of the circle, right, which is my base, is going to be pi r squared. So I'm going to find the volume. It's pi times the radius squared times 4, which is approximately 32 inches cubed. To find the surface area, I need to find the perimeter, which is the circumference, and that's 10. I need to multiply 10 by 4 plus 2 times the area of the circles. So the area of the circle is pi r squared. The circumference is 2 pi r. Surface area is 2 pi r times h. So it's 2 pi r times 1.54, 2 pi times 1.5415 times the lateral height, which is 4, plus double pi r squared, pi times 1.5415 squared. So the surface area is simply approximately 56 inches squared. I should say squared, they're not cubed. And that's it.